Hello, everyone. Now let's look at worksheet 8, solutions together. Question number 1. Find and interpret a 95% confidence interval for a population mean mu based on the following values. So we're given n, the sample size, equals 36. So sample size is 36, and x bar is 13.5, and s squared is 3.42. So when we're given s squared is 3.42, so that means sigma squared unknown, because we only know the sample variance s squared, which is 3.42. So when sigma squared is unknown, we're going to use the t critical value. So 95% confidence interval. So we have the formula x bar plus or minus the critical value times the standard error, which is the standard deviation over square root of n. And the standard deviation, if sigma is known, we're going to use whatever sigma value. And then in front, the critical value is going to be a z critical value. For this one, sigma is unknown. So we're going to use the sample standard deviation. And also we have a t critical value. So now we can plug in all the known information. X bar 13.1 plus or minus s, which is square root of 3.42. So we calculate that to get 1.8493, and over square root of n, which is 36. And the t critical value, we should have t with degree freedom n minus 1. And then we want to look at t sub alpha over 2, right? So t sub alpha over 2 is df equals n minus 1. So that is t sub 0.025, because 95% confidence interval give us alpha. That 95% confidence give us alpha equals 0.05, because 1 minus 0.95 is 0.05, and alpha divided by 2, so which is 0.05 divided by 2, so which is 0.025. And with degree freedom n minus 1, so n is 36 minus 1, so 35. So 35. So when if we check the t table, when the degree freedom is greater than 30, so that is the bottom of the t table, which is same as the z critical value. So z sub alpha over 2 is also equals 1.96. So that's how we got this critical value. Now we got everything. We just finished the calculation. Always calculate this part first. So that's 13.1 plus or minus 0.6041. And then that is 13.1 minus the margin of error, E, right? Margin of error, E, which is 0.6041. And 13.1 plus. So from 13.1 minus E, 13.1 plus E. So the lower and our upper bounds, right? That is our 95% confidence interval. And for the second question, same thing, sigma unknown, right? So we calculate the sample standard deviation, which is 0.3236, and n equals 64, which is larger than 30. So we got x bar plus or minus t critical value times s over square root n. So plug in all the information, 2.73 plus or minus, because it's also for 95% confidence interval. So the critical value is still 1.96, and finish calculation. So the 95% confidence interval is 2.645 to 2.8093. Now let's look at the second question. The following 10 observations are a sample from a normal population. So we got 7.4, 7.1, 6.5, 7.5, 7.6, up to 7.0. And we want to find the mean and standard deviation of this data. So since we're given a sample, so the mean and standard deviation are sample mean and sample standard deviation. So the sample mean x bar is sum of x over n. So everything add together. So we can use a calculator to get that calculated. So we have 7.4 plus 7.1 plus 6.5 plus 7.5, 6.5 plus 7.5 plus everything together into 7.0. After we type that into calculator, we can let the sum calculator. So the sum is 70.5 and divided by 10. So we got 7.05. 7.05. And the standard deviation, we can use the shortcut formula. So sum of x squared minus sum of x, whole thing squared over n and over n minus 1. That's the variance. So square root of that. So we can first calculate sum of x squared. So that's 7.4 squared plus 7.1 squared plus into 7.0 squared. So sum of x squared is 499.27. So then we can plug in. So this is square root of 499.27 minus 70.5. Sum of x is 70.5. We calculated that before. So squared over 10 over 9. Yeah. That is square root of 0.2494. That's square root of that. That's 0.4994. Standard deviation. So now we want to find 99% confidence interval for the population mean mu. Interpret this interval. So again, we don't have sigma info given, so sigma unknown. And then 99%, so alpha equals 1 minus 0.99, so 0.01. And we should choose the t critical value. And then the degree of freedom is n minus 1, 9. So we can first calculate the t critical value, t sub alpha over 2, with the degree of freedom. So 0.01 divided by 2, that's 0.005. That's why we have that here. And then with degree of freedom 9. And then we check the t table. So from the table, we got 3.250. That's a critical value. And then plug in all the known info, x bar plus or minus that 3.25 times standard deviation. We calculate it from the previous question. That's square root of n. So that is the 99% confidence interval. Okay, that's all for this worksheet 8 solutions. Thanks for watching.